another method that we have to seeing positions of our data and where the data values are in the set is what we call z-scores. And these are the mean and the standard deviation to give a relation to where in the data set it is. Essentially, the z-score tells us the number of standard deviations above or below the mean a certain value x is in the data set. And we can calculate this, our z-score for this data value x is equal to that data value minus the mean, and then divide that by the standard deviation. So let's do a couple of examples of calculating z-scores here. We have that a test involving 380 men, ages 20 to 24, found that their blood cholesterol levels had a mean of 182 milligrams per deciliter and a standard deviation of 44.2 milligrams per deciliter. And now with this, I want to determine the z-score to the nearest hundredth, 2 decimal places, for a man with a blood cholesterol level of 214 milligrams per deciliter. So now we have been given the mean, we have been given our standard deviation, and now I want to find the z-score for this specific data value, which is 214. And now that's going to be equal to this data value 214 minus our mean, which is 182, and then divide that by our standard deviation of 44.2. So now if we simplify this, this gives us 32 over 44.2, and then that we can simplify to be about 0.72. So now what does this mean? This tells us that they are 0.72 standard deviations above the mean. So that's the number of standard deviations away from the mean their cholesterol level is. The next one, we have been given the z-score for one man was negative 1.40. And now that negative means that they are below the mean and that they are 1.4 standard deviations below the mean. And what we want to know is what was his blood cholesterol level. So now on this one, we don't know what x is in our equation, but we do know the z-score. So we know that negative 1.40 is equal to x minus our mean, well, our mean is still 182, over our standard deviation, which is 44.2. And now we can work to solve this equation for x, our data value for this man. So I want to solve this equation for x, which means we want to get it by itself, which means we need to first deal with this division of 44.2. So I'm going to multiply both sides by 44.2 to cancel that out. So 44.2 times negative 1.40 gives us negative 61.88, and that's equal to x minus 182. And now to undo the subtracting 182, we can just add 182 to both sides. So that's going to give us that x is equal to negative 61.88 plus 182, which gives us 120. And then to round to the nearest decimal, we are going to have 0.1 for this. So then we have that their blood cholesterol level is 120.1. And then lastly, our unit would be milligrams per deciliter, because that's what we had been using for the unit for this. And then the last thing that I want to talk about with z-scores here is how it can be used to find the highest score between different tests and things like that. So when you have different tests and different data values from different sets, they have different means and different standard deviations. And they also probably use different scales for their evaluating of what they were using or trying to look at the data for. So with the standard deviation, our means, and the z-scores, we can sort of standardize the values to be able to compare things from other data sets. For example, think about how the ACT scores and the SAT scores are very different in the values that you get. ACT scores range from like 0 to 36, something like that, while the SAT scores go up to like 1800. Those are very different, but using z-scores, people could compare between the two tests to see what is similar in values with them. And with this problem, I'm not going to work through this problem here with our fitness scores, but we want to essentially find which fitness score is the highest relative score. And we can see between the three of them, the first one, they have a score of 42, a mean of 31, and a standard deviation of 6.5. The next one has a score of 1140, a mean of 1080, and a standard deviation of 68.2. And the last one is even higher values. So they're all very different. They're all treated with different scales for their fitness tests that they did. But we can compare it by finding the z-scores for each of the individual tests and their score that they earned on it. And with that, the one that's going to have the highest relative score, that's implying the one with the highest z-score. Because the highest z-score means that they are farther above the mean. Essentially, they did better than the average person, and they did even more better than the average person the higher their z-score is with this. Should be a positive z-score because we want them to be above the mean. So with this, you can calculate the z-score for each of the three tests and the scores that they earned on that test. And whichever one is higher, that's going to be the highest relative score when comparing them.